Hello, algebra. I lied about the perpendicular lines being the last lesson. Sorry about that. I forgot we redid the curriculum last summer and we added one more lesson at the end of this unit. So far this unit, we've done all linear equations. We're going to finish off with linear inequalities. So here we go with the last actual lesson for unit 2. One thing I want you to remember from unit 1, we did this a while ago, but we showed all solutions to an inequality by graphing on a number line. So if you remember, there's 0, 4 is on the right-hand side of 0. It's x is greater than 0, so open circle at 4. What numbers make that true? 5, 6, 7, so I'm going to shade that way. That should be something that you remember doing. One thing I want to remind you of is an inequality has often infinitely many solutions. There's one number that separates the solutions from the non-solutions, but on one side, there are countless numbers of solutions. That's why we need to graph them. Okay. You're probably like, okay, what's new? Well, let's jump down here. New stuff. In the inequality we just did, how many variables did the inequality have? Well, it was just one. It was x is greater than 4. What does the solution look like? Well, it was just a number. Because there was only one variable, a solution was just a single number. Today, we're going to be looking or working with inequalities involving 2 variables, which means a solution will look like an ordered pair. Or coordinates. There's an x part and a y part to our solutions. So let's jump in. Y is greater than or equal to 1/2 x plus 3. Now, the 1/2 x plus 3 should look very familiar. That's the mx plus b part, right? The only change here is the sign, okay? So what I'm going to do is I'm going to graph this just like I did earlier this unit. So I'm going to go up to 3. From there, I'm going to go up 1, right 2, and I'm going to do a few more. And then I'm going to draw the line. And earlier in the unit, that was done, okay? Before I go any further, I want to look at determine if the given point is a solution to the inequality. Okay, so 0, 0. All right, so 0, 0 is right here. We're going to plug that in. So I'm going to plug that into the original inequality. So I'm going to put 0 in for y and 0 in for x. And I'm going to see if that's a true statement. So 0 is greater than or equal to 0 plus 3. So is 0 greater than or equal to 3? No, it's not. All right. -2, 7. Change colors here. So 7 goes in for y. 1/2 x is -2 plus 3. Simplify the right side. That's -1 plus 3, which is 2. Is 7 greater than or equal to 2? Yes, it is. And let's go over here. -2, 7 is -2, 7. That's up here. Last one we're going to do is 4, 5. So put 5 in for y, 4 in for x, and we get 5 is greater than or equal to 1/2, or sorry, not 1/2. 1/2 of 4 is 2, plus 3, which is 5. Is 5 greater than or equal to 5? Well, it's equal to, which is part of the sign, so yes, it is. So 4, 5 is right on the line. Now, on one side of the line, the blue one, you had a true solution. On the other side of the line, the red one, was a non-true solution. On the line was a solution as well. Now, what does that mean? How do I show all of that? Well, what I need to do is I need to shade. Just like I did back on the number line, I have to shade one side of the line. Instead of being on one side of a number, though, it's on one side of a line. So the blue one was the solution, right? So I'm going to shade on that side. And then the points on the line, as shown by the green, are also solutions. That's why it's a solid line. Okay, so I'm going to clear all this. Hopefully you have it written down because I'm going to refer to it here on the next part of these notes. So the process is almost exactly like graphing lines, except for two things. You must make your line either solid, which we did here on this one, and that's less than or equal to, or greater than or equal to, or dotted, and we'll get to one of those on the back. And you use dotted lines with less than or greater than. The line separates the solutions from the non-solutions. I talked about that already. Just like the number that we found in Unit 1 separated the non-solutions from the solutions. You must shade on one side of your line. That shows that on one side of the line are the solutions, on the other side, they're non-solutions. Okay, the shaded region represents all the solutions to the inequality. Okay, so let's do a few more examples on the back. Well, a little bit more. To determine which side to shade, you must have your inequality in slope-intercept form. That's big. So make sure you have your inequality in slope-intercept form. If the symbol is greater than, so greater than or greater than or equal to, if it's one of the greater thans, then you shade above or up from the line. If the symbol is less than, then you shade below or down. This will all make sense when we do a few more examples. Now, one of the things I really see a lot of people mess up on is the solid dotted. Not so much the solid because they just don't think about it, but when it's dotted, it's easy to forget that. So I like to notice it right at the beginning. This one's going to be a dotted line. Why? It's not equal to. That means a point on the line is not a solution. So I want to make that a dotted line. Now I'm just going to graph it like I did earlier in the unit. Go up to 7, down to right 3. I'm going to do it again. And before I draw the solid line, I'm going to make sure it's a dotted line. Okay, and then I have to shade one side or the other. This one's in slope-intercept form. It's greater than. Greater than means above. So above the line would be my solutions. Okay, give just one solution to this inequality. Well, it's any point in that shaded region. Don't give one on the line because on the line is not a solution here. But in the shaded region, 7, 7. That's the point way up here. If I would plug 7, 7 in for X and Y, you would see that it would make a true statement. Okay. Number 2, -1. Oh, before I do anything, this is going to be a solid line. See, I almost did it there as well. You want to check that first. Slope is 5/1, so up 5/1. It's going to be a very steep line. It is a solid line, but it's steep. Now we need to shade. Okay, it's less than or equal to, so it's below. Now below might be hard with it being so steep. Best way for me to recommend doing this is put your pen or pencil on the line and just go straight down. What region do you come to? This one here. Okay. Pick any point in that shaded region. I don't like to go close to the line because it's just safer to be way out in the shaded region. I say that it's 5, -4. If I would put 5 and -4 in, 5 for X, -4 for Y, you would see that you get a true statement. Okay, 2 more. 3X or 4X plus 3Y is greater than or equal to 9. And then number 4, 4X minus 6Y is greater than 24. What do you notice, or what do you have to do to these first? You have to put them in slope-intercept form. That helps with the shading. So we're going to do that. You've done this before. There's nothing new here. Subtract 4X. So -4X plus 9. divide by 3. You're dividing by positive 3, does not flip the sign. Now I'm bringing back an old concept here. Flipping the sign. I don't have to do it here because I divided by a positive. But if I divide by a negative, I would have to flip the sign. All right, so this one's going to be a solid line again. Go up to 3. And then go down 4, right 3. Do it again. Oh, that was pretty terrible. There we go. And then shading above the line, so it's going to be up here. All right. 3, -1. Is 3, -1 a solution? So 3, -1, that's on the line. Is that a solution? Yes, it is. And if you want to make sure, plug 3 in and -1 in, and you should get a number that makes it true. All right. Number 4, you want to move this into slope-intercept form. So I'm going to subtract 4x. That gives me -6y is greater than -4x plus 24. And then divide by -6. Now, right there, I referenced it in number 3. We divided by a negative. That flips our sign. Make sure you notice that. Sign got flipped. Negative divided by negative is positive, and then reduced to 2/3 -4. So down to 4. Oh, by the way, this is going to be a dotted line. Make note of that. Up to right 3. And there's my dotted line. Now, I'm using the transformed equation to determine my shading, and that's less than, so it's below. If I use the original equation, it was greater than, and I would shade above, and I would have all the wrong solutions. Okay, that's why it's very important to get it into slope-intercept form. Is 6, 0 a solution? Again, that's on the line. In this case, because it's on the line, it is not a solution. If it was on the line with a solid line, it would be a solution, like number 3. Okay, that concludes this lesson. It also concludes our unit. Test will be coming up very shortly.